Hello everybody and welcome back to my YouTube channel and आज हम लोग discuss करने वाले हैं regarding biostatistics. So there is hypothesis testing, there is types of errors, there is t-test, there is z-test. So hypothesis मतलब क्या? Any चीज, any assumption or a proposition of a statement. आप कोई चीज को imagine कर रहे हो कि ये चीज hypothesize हो रही है. जैसे कि we hypothesize that 50% of the people in India staying are belonging to the middle class family, right? So ये मेरा hypothesis हो गया. So there are two types of hypothesis, null and alternate. We will be discussing it in further lecture today. So yes, let's start. When we speak about hypothesis, so there is null and there is alternate hypothesis. So null hypothesis is what? That there is no difference with the null attitude. कोई difference ही नहीं है. Okay. And when we talk about alternate, it is complementary to null, which means there isn't a difference, right? So alternate can be either one-tailed or two-tailed. That is, one tail maybe it can be either left or right. So for this we need to know about this normal distribution curve. So this is a normal distribution curve. This particular area is the acceptance region. This particular area is a critical region, and beyond that is the rejection zone, right? So in this region, anything that falls in this region is accepted, and anything that falls beyond the critical region, it is said to be rejected, right? So it can be one tailed, that is only left tailed, or it can be one tailed again, that is only right tailed. So या तो only positive side पे होगा या तो negative side पे होगा, या it can be two tailed, both the sides. So that is what is here you can see it can be right tailed, left tailed, or two tailed. That is similarly we have designed t-test also, t-test, one tailed, two tailed t-test and all. Okay. So this is what the graph that I was talking about. This is the critical region, and beyond this lies the rejection zone. ये जो है हमारा acceptance region है. ये जो हमारा center है, that is mean. So at this point there is 50-50% of the distribution. So confidence interval, there is one terminology that is called as confidence interval. We majorly have three types of confidence interval at three levels: 90%, 95%, and 99%. And similarly, level of significance, that is LOS. It will be for 90%, it will be 10%, for 95, it will be 5, and for 99, it will be 1%. So we write it, represent it as alpha. So alpha will be in case of 0.1, in case of 10, in case of 5, it will be 0.05, and in case of 1, it will be 0.01. So there are three levels of significance and three confidence intervals where we mostly measure a particular data set. So yeah, critical region, and that is what is importance of critical region around here. So left tail here you can see it is left tail, here you can see it is two tailed, and in the previous image it was right tailed. Now that there are two types of errors, type 1 and type 2. So in type 1 error you call it as false positive result, and type 2 error you call it as false negative results. Okay. So type 1 mein why do we call it as false positive? Because your hypothesis is true, but it is still rejected. However, in type 2 error, your hypothesis is false, but it is accepted. मतलब वो झूठ है, लेकिन फिर भी हमने उसे अपनाया है. That means hypothesis is false, but still the decision is accepted. But in case of type 1, hypothesis जो है वो सच्चा है, true है, हमारा सच्चा दोस्त है, लेकिन हमें उसकी कद्र नहीं हुई. We rejected it, right? In the real life as well, we can correlate it. We have friends who can be snakes as well, and who can be the one who can be along with you for a very long time. So hypothesis true होके भी उसे reject कर दिया. So that is type 1 and type 2 का difference. Type 2 1 is represented by alpha and type 2 is represented by beta. So beta can be also useful in the testing of power of a test. So higher the power of a test, lesser as the chances of type 2 error to be occurring, right? So power is equal to 1 minus beta. So you can see hypothesis is true and accept, that's a correct decision. Hypothesis is true but rejecting, ये रहा is ये case है. So there is type 1 error. Here hypothesis is false and you're accepting it, type 2 error. Hypothesis is false, उसको reject कर दिया, that is type 2 that is correct decision. You have to reject it if the hypothesis is false. So here you can see type 1 error, type 2 error, level of significance, all that I was talking about. Sample test. So there are two types of sample test: when the sample size is less than 30 and when the sample size is greater than 30. Okay. So the sample size, whenever it is like around 30 or so, less than 30, we use the t-test, and whenever it's like more than 30, we use the z-test. So the samples, a small sample test is the t-test. So for the t-test, we have the formula x bar. Even for the z-test, we have the same formula: x bar minus mu upon sigma, the whole upon square root of n. N is the sample size, sigma is the standard deviation, x bar is the sample mean, and mu is the population mean. So you have to subtract the sample mean from the population mean, and then you have to determine. So many times the question has been asked on properties of t-distribution. So you need to know that mean, median, mode is equal, and there is a degrees of freedom. So whenever you're taking out t-test, all you have to remember is degrees of freedom. So there is a table of t-test in which you have to see the degrees of freedom. So suppose my sample size is 12. So my degrees of freedom will be n minus 1. It will be 11. So in the table, I will be looking out the degrees of freedom at 11, not at 12. So that this is a very crucial step. Here you can see t-test. Can you see the statistics? So here they have seen. Here you can see the degrees of freedom they have calculated. So you have to compare your calculated value with the degrees of freedom, the value that you obtained from the table. So if your calculated value is greater, remember, very important, if your calculated value is greater than the tabulated value, you will reject the null hypothesis. If your calculated value is less than tabulated, obviously एक range होती है, अगर उस range से कम होगा तो ही accept करते हैं ना. Even in IP we have so many ranges of weight variation and disintegration and all. So if it is less, then only we accept. If it's beyond that, we reject it. Similarly, our calculated value should be less than the tabulated value, तभी ही हम उसे accept करेंगे. Okay. So this is what is same thing, that hypothesis that I've been talking about. I'll just show you all the table so that you'll come to know. This is a two sample t-test. Okay, this is an example of two sample t-test. So in this you have n1 minus n1 plus n2 minus 2. This will be your degrees of freedom. Okay, since we have two different types of data sets and two different values. So this is a formula that you can apply: x minus x bar the whole square plus y minus y bar the whole square upon n1 plus n2 minus 2. So this is a formula for standard deviation, and for t-test it is x bar minus y bar upon sigma 1 square root of 1 upon n1 plus 1 upon n2. Okay, this is a formula for two sample t-test. So this is, and this is in mod, obviously it will be positive value only for two sample t-test. So please remember, this is very important, and you cannot just remove the mod, because mod हटाया तो in case value negative में आ रही है तो आप negative value में ही देख लोगे. So that is not all right. You have to keep it in a mod. So this is what is important when I talk about two sample t-test. You have to use this formula x bar. You have two different this thing data sets, right? So x bar will be representing east coast here, and y bar is representing west coast. So two different data sets. So similarly, you will get two different sample size n1 n1, and sigma 1 will be common. So because x minus x bar, y minus y bar, you're considering both of them in the standard deviation. So this is very important formula for two sample t-test. Here you can see they've removed the standard deviation for two sample t-test. Same over here. And now your CFC. So yeah, see over here. Your calculated value is 2.16 and your table value is 1.83. How did they get this 1.83? Degrees of freedom same. So n was 10. Now they looked at the table and the degrees of freedom at 9 and 95% confidence interval. So they have got the value of 1.83 from the table. Here you can see this is a table. So here you have to see at degrees of freedom at 9. Can you see? And the confidence interval of 0.05 over here. Because 95% means 0.05, right? So here you can see 9 and 0.05. Is it 1.83? Is it 1.83? Yes, it is 1.83. So that means you calculate your value. How did we calculate? I'll repeat it again. Your sample size was given as 10. So your degrees of freedom will be n minus 1, which is 9. So 9 is line में जाओ और 9 को देखो. अभी यहाँ पे it is the upper cell probability, where it is mostly 0.05 because 95% is the confidence interval that is considered in most of the cases. But be careful, sometimes they given 90%, 99%, 97%. So in that case, it will be changing. And here you can see it is 1.83. Can you see over here? So this is very important that you come to know how do you calculate the tabulated value, because हम calculate वाला तो कर लेते हैं formula लगा के, but हमें table value से compare करने का, that is main. because your inference, your conclusion to accept or reject null is based upon this tabulated value only. So this is how you calculate the tabulated value. And in next lecture, we will be discussing about ANOVA, one-way and two-way ANOVA. So that's all for today's lecture. I hope you all did enjoy a lot about and learn about t-test. If you all have any doubts, you can get back to me and drop your doubts in the comment section and queries. You can solve these sums and that I just shown you by taking screenshots of the same and compare your answers. I have mentioned the answers as well. So that's all for today's video. Thank you so much for watching the video.